Day, Sir Aldrin J. Soriano. This is the part 2 of the midterm laboratory activity 1. So let us begin by creating new project. And for the project type, we will choose Atmel AVR Assembler. And for the project name, we will name it as Activity 2. So, and then for the location, we will change this location. And we will choose the Activity 2 for the folder. And then click Next. For our debug platform, same as the activity 1, we will use AVR Simulator. And for our device, we will use ATmega32. And then click Finish. So after that, we will proceed with the coding. So since the code is already given, we will just insert it and the instruction is being flashed on the screen. So let's begin. So let me just input the code first. So I will just input the code since it is already given and the code is already flashed on the screen for you to follow it. Since we are done, okay. So since we are done, the instruction states that we have to examine the flags and the registers and the register content of it. So let us first assemble this to verify if there are any errors present in this code. So it is still loading. So there, as you can see, there are no errors and the code are okay. As you can see, the code has no errors and zero warnings. So let us now assemble and run the code. Okay, so let us just expand the registers and use single step to examine it. So we know that the flag does not change its value on the LDI instruction. So we can focus on the subtraction on the sub instruction instead, where there will be changes. So, okay, let us use the single step. So, okay. Mhm. So, after the first sub-instruction, it is observable that there is no flags that changes its value. So, as we proceed, so let us proceed with the second sub. So there, as we proceed with the second sub, we monitor that the status register has turned on the half carry flag here. So the half carry flag has been turned on, meaning the resulting value after subtracting the R20 and R21 has exceeding 4-bit or the lower nibble of the 8-bit status register. So again, we're going to skip the LDI instruction and proceeding to the next sub instruction. So there, for our third sub instruction, which is the the sub R24 and R25, as you can see, our zero flag has been turned on, meaning the previous instruction has the resulting value of 0. And then let's proceed again with our last sub. So with our last sub, which is the sub R20, register 22 and register 23, which are being subtracted, the flags half carry, sign flag, negative flag, and carry flag are turned on, meaning the resulting values of this has exceeded the 8-bit of the status register, as well as the lower nibble of the 8-bit register has exceeded the 4-bit value. So after examining our status register and observe the value, so okay, I'm sorry. After examining the status register, we can reset this. Oh wait, let me check. Okay, let me just reset this one. Okay, and then use the single step. There, as you can see, the load value of each register is changing according to its load, and once it goes to the sub instruction, the value also changes. So there. So the value is changing as we load and sub the registers. So that's it for the activity 2 in the midterm laboratory activity 1.